assignment, but so we are running in Nordita the program which called geometrical aspects of string theory. So that runs from 1510 till 1512, and so it's Ulf Lindström and myself who are organizing this. So the word geometrical was chosen on purpose in order to get funding. The word mathematical existed previously in application to Metaklefleur, and it didn't get funded. So, I will discuss all these issues, but of course geometry, it's by definition, it's part of the math, but there is some funding issues and people nervous about some words. And one of the goal of my talk, again, I'm going to tell you in very general terms, just advertise, but one of the message I will try to deliver, please, this is message toward physicists. Physicists shouldn't get nervous about words geometrical and mathematical, but also mathematicians should get nervous about the words like physics, etc. So we are running this program. There are many people are coming, and as you can imagine, some of the people are math people. So again, this is some of the guests are math people. And you can look at the program on the net, and you're welcome to attend any seminars. But again, I'm not going to talk about really very much about the program organization. I will talk about science and why geometry is good for string theory and why string theory is good for geometry. And so I will give you a few examples, some amazing results in math coming from physics. And also I will try to explain a few hot topics, which are hot during last, maybe 5-10 years. So it's basically, I will talk specifically, again, I will do it in very primitive way, not mirror symmetry. So mirror symmetry. Then there is another big word, it's Langlands duality. Duality. Or Langlands program, it's a better word, program. Again, I will give you a very, very rough idea, non-expert, why math people are so excited and one physicist should be excited and what's the contribution, and then maybe this is more close to my personal area of research, it's generalized geometry. Okay. So let me just basically wrote you some experiment. Okay, that's good. So Nordita will remember us forever. And I'll try to use the rest. So let's just, let me remind very trivial facts about geometry of 20th century and about physics. So if you look at, again, the word geometry, I have to check that it works, right? It works. So the word geometry, I will use also the word is math. But again, I'm on purpose, I didn't use this word in application and the name just not to make some people nervous. Okay, so and then there is a physics. So very roughly, if you look at the history, then I think if you look before beginning of 20th century, then it's quite often hard to differentiate who we're doing physics and who we're doing math. And again, when I talk about physics, I'm talking, of course, not about experimental physics, I'm talking about fundamental physics. And then things started to diverge a bit, and then here basically it's times when we had a general relativity, we had a quantum mechanics, right? And then things got very wild, especially in the middle of the century. So this is why the picture I'm drawing is due to ITEA. So, and I just saw in one of his lectures this picture, so I think that's what would be physics, that would be math, okay? And then according to ITEA, things started to converge, and then basically things were very bad in 50s, up to 70s, but that was, and then the marriage happened, and according to ITEA, the main reason for marriage is here, string theory, or, many activities related to this, and then, according to ITEA, we have 25 years of marriage. A happy marriage. Okay? So,
Is it intentionally asymmetric?
No, it's unintentional. It's just because of my drawing skills. Let's downscale. But what I wanted just to show, or ITEA wanted to show that, definitely, for the 20th century, this is peculiarity of development of physics and math, that, you can, if you pick somebody, you can specify, if you pick up Elie Cartan, you wouldn't call him physicist. If you pick up, Feynman, you wouldn't call him mathematician. So it was, very, very clear who is doing what. And again, that's, started here already. So at the beginning of the century, people typically would call Poincaré is doing, geometry or math, and Einstein would do physics, so things started. While, if you go to mid of 19th century, then, you still can call Maxwell had contribution both to physics and math, and some other people. So it was really separated. Now, if you look what was going on in physics and geometry here, so in geometry, what was going on, that basically due to Elie Cartan, by 1930s, we got a very well developed differential geometry. So it was based on the works of Riemann, Levi-Civita, Sophus Lee, but then Cartan came up with a good summary of everything. Then also, again, it was big development in topology. So topology became as a proper subject here. Then, I can list homology. Then the very, very big breakthrough, it was algebraic geometry. And let me mention one name, it's Rothenberg. So it's in middle century. And then, all this impressive line, presumably one of the biggest achievements of geometry, it's index theory, which basically relates topological to analytical properties of the manifold. So you can do some analytical calculation and get something about topology of the manifold. So if you look at the physics here, well, I already wrote something, so it's a general relativity, basically, and more or less at the same time, a bit later, it was quantum mechanics. Then, in the middle of century, we got what's called quantum field theory.